To reduce radicand means simplifying numbers inside the radicand by factoring out perfect squares, perfect cubes, and etc. First, I'm going to introduce the radical. This A represents the radicand, this represents the radical sign, and this N represents the index. Also, you should memorize the perfects, like the perfect squares, the perfect fifths. Let us now move on to give examples in reducing the radicands.
So for the first examples, we will start by doing the easy ones. And the first question is square root of 50. Now, to reduce the square root of 50, we start by looking for perfect squares that fit inside 50. Since 50 can be written as 25 times 2 and the square root of 25 is 5, we bring the 5 out of the radical while the 2 stays inside. This changes the square root of 50 into the simpler form and our final answer, 5 square root of 2. Let's answer 4 more equations. Square root of 72, square root of 32, square root of 12, and square root of 75. Let's answer square root of 72 first. Now, one way to reduce square root of 72 is by dividing it by the largest perfect square possible. The largest perfect square that divides 72 is 36. So, we rewrite 72 as 36 times 2. Since the square root of 36 is equals to 6, we pull out the 6 and keep the 2 inside the radical, giving us the final answer of 6 square root of 2. Let's move on to square root of 32. To make square root of 32 simpler, we factor 32 into numbers we know well. Since 32 is equals to 16 times 2 and 16 is a perfect square, we take out the square root of 16, which is 4. This leaves only square root of 2 under the radical, so the square root of 32 becomes 4 square root of 2. Now, for square root of 12, a quick way to reduce square root of 12 is to list its factors and look for a perfect square. The number 12 can be written as 4 times 3, and because square root of 4 is equals to 2, we can bring out the 2 and leave 3 inside the radical. This gives us the simplified form 2 square root of 3. Easy, right? Now, to simplify square root of 75, we check whether 75 contains a perfect square factor. In this case, 75 contains 25. So, we write it as 25 times 3. The square root of 25 is 5, so we take the 5 out and keep the square root of 3 inside, forming the final answer of 5 square root of 3. Now, for the last easy examples, it will be square root of 27. To reduce the square root of 27, we break it into factors and choose the perfect square. Since 27 is equals to 9 times 3 and 9 is a perfect square with the square root of 9 is equals to 3, we move the 3 outside the radical. The 3 that remains stays inside, which gives us the final answer of 3 square root of 3. Now, it's pretty easy, right? Now, let's move on to the medium examples.
Hi, so I will be explaining medium level of reducing radicals, and I will be explaining and give them 7 examples. So, let's have an example of the square root of 32. So what we'll do is that we'll break this number down into 2 numbers that will be times together and we'll have the exact given number. And those numbers will be 16 and the number will also be 2. And that'll come out as square root of 16 and square root of 2. And since we have the square root of 16 here, we'll have that simplified into number 4. And that will come out as 4 square root of 2. That's your answer. And it is just that easy since we're going to simplify it. So how about let's go and have a 7 examples. So here, an example, we have the square root of 75. And since 75 is a perfect square, we have 25 times 3. And when you times 25 times 3, that will come out as the square root of 75. And the number will be 5 square root of 3. So let's head to the next part. We have the square root of 48. So the factors of 48 is that we have 16 times 3. So if you times 16 times 3, that will be 48. And since we have the square root of 16, that will be equals to 4. So the answer will be 4 square root of 3. That's just the answer. We're just going to break it down to pieces. And in the next part, we have 180. The square root of 180. So we just do the same. So the factors of square root of 180 is square root of 36 times 5. And then that will be equals to the square root of 36 equals to 6. And the answer for that will be 6 square root of 5. And those are the examples. So the next examples are, so let's say we have the square root of 200. So we'll just do it just the exact thing we did earlier. We have also the example of square root of 72 and then the square root of 98. Three examples, right? And so let's head off for the square root of 200. The factors of 100 is 100 times 2. And then we will have the square root of 100 into 10. So we bring that down, we have 10 square root of 2. Example number 5, 72. The square root of 72. So the factors of 72 is the square root of 36 times 2. And then the square root of 36 is 6, 6 times 6 is this perfect square, and that will be 36. So that will bring it down, and then we have 6 square root of 2. Next part, square root of 98. Again, the factors, you will have the square root of 49. Yes. And 49 times 2. Those will be the factors that we will times together, and the answer will be 98. 49. Oh, wait. 49 times 2. And the perfect square of 49 is 7. So we'll have 7 square root of 2. Last example is the square root of 300. This one is going to be easy because we have the factors here, 100 times 3. And then the square root of 100, of course, is equals to 10. So we'll bring it down. We have 3 and there we go. 10 square root of 3. That's all. Thank you.
Good evening. I am Eisha and I will be presenting the hard examples.
How did I get 3x cube root of 2x? Using the formula in the given, we will copy the given and solve it on our own. We first get the factors of 54. Since 27 times 2 is 54, it is the factors. And since it's cube root, the factors of x is x cubed and x. And finally, we just get the cube roots. The next given is square root of 196 a cube b cube. 196 is a perfect square, which is 14 times 2. We can put 14 out of the square root. Since a squared is a factor of square root and b raised to 4 is a square root, so it is a value of 2. The next equation is square root of cube root of 243 x raised to 17 y raised to 23. Since 81 is a factor of 243, we can now put it outside of the cube root and put it in the square root. And then we can now factor out x raised to 17 and y raised to 23. Since x raised to 15 is x raised to 5, y raised to 21 is equal to y raised to 2 raised to 7, and we can now put x squared and y squared into the cube root. Now we find the square root of the given. 27 times 3 is equal to 81, and then we can factor x raised to 5 and y raised to 7. Since x raised to 4 and y raised to 6 is factorable by 2, this is now the answer.
I'll show you some more examples. In here, let's say the cube root of, let's say, 16 x 4. We're gonna get the factor, which is 8 times 2 x squared and x. The perfect cube of 8 is 2 x squared cube root of 2x. Next, let's say the square root of 8x cubed. So that's 4 times 2 times x squared times x. And then the square root of 4 is 2, and then the x equals 2x. Last one example. The square root of, let's say, 18. 9, 2, 2. So the answer was 3 square root of 2.